In this very lesson, we shall be looking at the complement of a set. Complement of a set. So we are saying that if set A is a subset of the universal set, then the complement of set A is a set of all the members which belongs to the universal set but does not belong to the subset. So what we are saying is that if we have a universal set and then we have a subset of the universal set, then the complement of the subset are all those elements that belong to the universal set but does not belong to the subset. An example is, let's take it that you have the universal set U which contains the elements, and then we have a subset of the universal set, let's call it set A, and then set A contains the elements 6. Then the complement of A are all those elements in the universal set that are not part of set A. So to get a clearer picture, we are going to use the cancellation method to enable us to fish out all those elements that belongs to the universal set but does not belong to set A. So we have 2 will cancel 2 in the universal set, 4 will cancel 4 in the universal set, 6 will cancel 6 in the universal set. So all those elements in the universal set that remains uncancelled becomes the complement of A. So you can say that A complement, which is normally written as this, we have 1, 3, 5, 7, and then 8. So the complement of A, we have 1, 3, 5, 7, and 8. So it means that all these elements are in the universal set, but they are not in what? The subset A. The complement of a set is mostly denoted with A prime or A complements a superscript C or A dash. So if we have B complement, it is going to be B complement, which is also known as B prime or A prime. Then we have B complement or A complement. All these symbol means that we are talking about the complement of the subset of the universal set. Let's take another example. So if you have the universal set and it contains the elements A, B, C, D, E, and then F, and then we have a subset of the universal set, let's say X, and it contains the element B, D, and then F, and then we have to find what? S complement, which means that we want to look out for all those elements that belongs to the universal set but does not belong to the subset X. So as I said, we are going to use the cancellation method. B will cancel B in the universal set, D will cancel D in the universal set, F will cancel F in the universal set. So those members or elements in the universal set that remain uncancelled becomes the complement of X. So we have S complement. So we are left with A, C, and then U. So these are the complements of the set X. Now, complement of a set, you can also use the Venn diagram to represent it. Good. So we are saying that we have a universal set U and then a subset of what? The universal set, which is X. So in representing it using the Venn diagram, we have this, and then we have our universal set. We are having only one subset, which is X, so we are going to draw only one circle. So this circle represents what? X. So we can decide to write the element of X in the circle or just write X within the circle. So the complement of X will be those empty space around this circle, but they are within the universal set. So all these shaded portion becomes all the shaded portions becomes the complement of X. In other words, you can decide to draw. You have your universal set, you have the subset set X, it contains the elements D, D, and then what? F. And then the complement of the set, we are going to write it outside the circle. So we have A, C, and then E. So we can use what? The Venn diagram to represent the complement of a set. So all those shaded region outside the circle become the complement of what? Set X. Let's take another example. So we have example 3. Given that so we have our last example. It reads that given that you have the universal set and contains this element, and then we have a subset of the universal set which contains this element, we have to find the complement of A and then represent it on the Venn diagram. So what we are going to do is that we are first going to list the element of this particular set, the universal set, and then we list the element of set A. So let's list the element of the universal. So we are first going to list the element of the universal set. So we are saying that we have a set of what? Integers. S is such that S is greater than -5, but S is less or equal to 5, where S is an odd integer. So when we talk about integers, we are referring to positive and negative whole numbers. So in listing this particular set, we are going to start from where? -4, -3, -2, -1, 0, 1, 2, 3, 4, and then 5. So this becomes our universal set. Then let's list the element of set A. So we are saying that S is such that S is greater or equal to -3, and this X is what? Less or equal to 3, where X is an integer. And we know that integers are positive and negative whole numbers. So it means that we are going to start from where? -3, we move to -2, -1, move to 0, 1, 2, and then what? 3. Now we have our universal set and then the subset. So the next thing that we are supposed to do is to find the complement of this particular set. So the complement of set A, which is written as A prime, we are going to look for all those elements that belong to the universal set but cannot be found in the subset A. So as I said, we can use the cancellation method. So let's use that one. So we have -3, -3 will cancel that, -2 also cancel, -1 will cancel, 0 will cancel, 1 will cancel, 2 will cancel. So those elements that remain uncancelled in the universal set becomes the complement of what? Set A. So we have -4, we have what again? We have +4, and then we have what? 5. So this set becomes what? The complement of set A. So the last question says we have to represent it on the Venn diagram. So we have our rectangular box, and then we have our universal set. We are having how many subsets? We have only one subset, and that is what? Set A. So we have only one. We are going to draw only one circle. So this circle represents what? The subset A. And then all those regions around the circle becomes what? The complement of set A. So we can write it as this. So this is the Venn diagram representing this particular set and its complements. This brings us to the end of today's lesson. See you tomorrow. Bye bye.